Hello everyone, I'm Caroline. Welcome to our Fine Math Practice, the Day 3 tutorial video. And now let's see the question, the labeling technique. Actually, this question is a little harder than the last question, right? But it is not complicated. You just read the question. It's a square, yeah, this one. Want to this square. Want to find some food from point B. So this square needs to go from point A to point B. And the question is, there are how many different shortest roads to choose? Okay, so this word is the key point. It's very important. Shortest means you just go ahead and don't come back. Like I go to B, I can like this, but I cannot do like this from use another color. If you go like here, like this, I don't think this is the relatively short way, right? So you just go ahead and you cannot go back. Okay, so how can you use that? You can use the labeling technique. Yeah, you can mark the number in the each points in this figure. Okay, like here, yeah, that's all the points I marked it. You need to find the corresponding ways, like this one. We call it C and D. So how many ways do you have from point A to C and D? So here is one, here is also one, because only one direction, right? And for E, F, G, H, I, blah, 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 blah. Okay. So here for E, you can see we can go from A to C and then to E. So we also can go from D to E. So actually we have two directions, right? So for E, it should be the sum of this one and this one. So it's 2. Yeah, this one is 2. Okay, and then for G, somebody just mark here is 3, but it's wrong. Why? Everybody, you need to find the relative short way. So if you want to go to G, you only can start from A to D and to G. You cannot go from A to C to E to this point or N to G. No, it's impossible. It's a time-consuming way. Yeah, so you only have one direction. Yeah. So do you find a pattern? If you want to find the relative short way, you only can start from the left to the right, or from the down to up. Yeah. Ooh, where is my result? Okay. So for G, we only have one way, and for H, also one way, right? So for F, it's also one way. For I, okay, for I is not one, because for I, you can go from the left to the right. Yeah, from A to F and to I. This is one way. Or you can from E to I, like from here to E to I, it's a way. Or from A to C to E to I is also another way, right? Because from A to E, you have two ways. So, of course, if you want to throw E to I, you also have, yes, two ways. So, for I, from A to I, the number of ways should be the sum of F and E. So, it's 1 plus 2 is 3. So, here's 3. And this point, you can from E to this point, or from G to this point, so it's 3, 2. And for this point, should be the sum of 3 and 1, so it's 4. Yeah, and for this one, it should be 3 plus 3 is 6. And for this one, 6 plus 4 is 10. Okay, so the key point is here. What about this point? If I call it M, yes, I can call it M. So how many ways do you have from A to M? Actually, if you want to go to M, you only have one direction, right? From this point to M, right? So the ways of this point is 6. And you only have one way, so it's also 6 ways from this point to M, right? And then for B, it's just 6 plus 10, it's 16. So actually the answer should be 16. 16 ways, that's what. This is the labeling technique. You only need to mark the corresponding ways of each point and to find from A to B. In total, we have how many points? That's all. Oh, we have how many ways? Okay, that's all. Okay, the next question. The Newton's problem of coils and fields. Actually, this question is easier than the previous 2 days. Yeah. The difficult part is you don't understand the question. So, Caroline just strongly recommend you to read the question again and again and tell what's the key point in this question. Okay, so let's read the question together. On a piece of grass, the growth of grass is the same every day. The growth of grass is same every day. Suppose that 1 sheep eats 1 shear of grass a day, and 5 sheep add up the grass in 4 days. 6 sheep add up the grass in 3 days. In order to maintain sustainable development. Okay, what's the meaning of sustainable development? In Chinese, we call it 可持续发展. So, you can see the meaning in the bracket. That is, the grass cannot be eaten up. Cannot be eaten up. It means this pasture should be always there. It cannot be eaten up. And then we need to think about it. If our total grass is going down or is decreased every day, I think in the future, this pasture will be eaten up, right? 如果草地上的总草量每天都减少一点点，那最终它一定会消亡。So if you want to maintain sustainable development, it means your total grass should be grass or just to keep still, right? Just to keep still every day. As long as they decreased a little each day, in the future they will, be eaten up, right? So this is our goal. And then you need to analysis. What is the total grass made of? The total grass is about the original grass and the new grass, right? The new grass, do you know the growth rate? The growth rate? No. So this is the thing you need to calculate, right? Because now we don't know how many shears of new grass will be grown every day. So that's the thing we need to calculate. Very important. Okay, how can you calculate? Let me clean this part. Okay, use the 2 situations. 5 sheep add up the grass in 4 days. So in total, they add up 20 shears, right? 20 shears in 4 days. And this should be the original grass and the 4 days new grass. Original grass, new. And 6 sheep add up the grass in 3 days. So in total, they just add up 18 shears. Okay, and this 18 shears include original grass, the same original grass, and 3 days new grass. Okay, and the difference. The difference actually is here. Let me use the red pen here. Okay, actually it's 2 shears. And this 2 shears actually is for 1 day, right? It's for 1 day. So our growth rate actually is 2 shears per day. This is our growth rate. Our growth rate. Okay. Someone will ask, oh, Caroline, how should we do next? Okay, now we know the total grass include the original grass and the new grass. You need to maintain the sustainable development. You cannot make the total grass decrease. So original grass is fixed, right? It's fixed. And the new grass will 2 shears per day. If you want to make sure that the total pasture cannot be eaten up, then it means we only can eat. We only can eat the new grass, right? I mean, the total grass, not the total. I mean, the grass you eat every day cannot over 2 shears of grass, right? As long as you over 2 shears grass, it means you will eat the original grass. And it means your total grass will just decrease every day, right? So in total, in one day, we can just eat 2 shears of grass at most. And we know 1 sheep eats up 1 shear of grass a day. So this 2 shears grass, we only can appoint 1 sheep to eat them, right? So here we should just fill 2 sheep at most. Yeah, the grass line or the pasture only can support 2 sheep at most. That's all. Okay, so understand? Every time when you want to get the correct answer, just read the question carefully. That is a very important habit during the mathematics. Okay? So today's tutorial video is end. See you next time. Bye-bye.